welcome back. We were discussing in Fundamental of Electronics about the BJTs, that is Bipolar Junction Transistor. In this lecture 8, we are going to discuss on power amplifiers. So let us see the overview of the power amplifiers. So when we see the input signal which is given to the bipolar junction transistor, if it is small, then we need to amplify that to use the full load line of the BJT. There are certain stages that you have to be use the BJT. First is basically the small signal transistors whose power rating is less than 1 watt, and it is used at the very early stage of the system, and it is used the low power. Whereas the power transistor, as the name suggests, this is the power transistor. So these are large signal transistor whose power rating is greater than 1 watt, and it is used in the final stage of the entire system, which is giving the high power at the output. The load impedance, which is lower and will be at the later stage of the entire system. For example, if you take one stereo speakers of resistance 8 ohm or less. So when we talk about a system, there are many stages where the transistors are used. Some transistors are small signal transistors, some transistors are large signal, or otherwise we say that to be power transistors. Now if we differentiate the voltage amplifier with the power amplifier for the features such as the purpose for which it is used, what is the voltage and the current gain, similarly the power gain, load impedance, output power, collector current, transistor type, heat dissipation, and the applications. So easily we can differentiate this voltage amplifier with power amplifier. Like for example, if we talk about the purpose, then voltage amplifier will increase the voltage level of the signal, whereas the power amplifier will deliver high power to the load. Voltage gain, if we talk about the voltage amplifier, it is high, but it is moderate in power amplifier. Similarly, the current gain and power gain is low to moderate in case of voltage amplifier, but it is high in case of power amplifier. So power amplifier, generally we can think of the current amplifier because it is basically increasing the current. Obviously the power also increased. Load resistance is high in case of voltage amplifier, but it is low in case of power amplifier. Output resistance, and hence it is low in voltage amplifier, whereas in power amplifier it will be high. The collector current is small, usually in the milliampere range in voltage amplifier, but in power amplifier it is large in ampere range. So the voltage amplifier are basically the low power transistor, whereas power amplifier are basically the high power transistor. Heat dissipation will be low because the current is less, whereas the current is high, so heat dissipation will be high and it will require the heat sink for the cooling purpose. If we talk about the application of voltage amplifier, this is used in signal processing as the pre-amplifier or operational amplifier, whereas the power amplifier is used in driving speakers, radio frequency transmission lines, and the motor control. So our focus will be on large signal amplifiers, which are basically the power amplifiers. We have already covered the voltage amplifier in the previous lecture series 7th. Now we focus on large signal amplifier. So large signal amplifier is using a large portion of the load line. So we have seen the load line characteristic and what is the use of the Q point in the load line. So this Q point location in the load line plays an important role. We have discussed this in very detail in the previous few lectures about the quiescent point and the load line. But here, what is the major part is we have to use the large portion of the load line, and hence different class of the power amplifier are there, like class A, class B, class AB, and class C. So these differences in the power amplifier is because of the use of the input cycle in the linear region. If you use 100%, then it falls under the class A amplifier, whereas if you use 50% only, then it is class B. Amplifier which is using 50 to 100% of the input cycle, that is class AB, and if it is less than 50%, that is class C. We will discuss this amplifier in very detail. Application, when we talk about the power amplifier, this is usually used in the final stage of the communication system in receivers or transmitters. It provides power to speakers or antennas. Let us take an example like BJTs illustrate power amplifier principle. So obviously this power amplifier will be the last stage or the final stage of any particular system, whereas the beginning stage we will use the voltage amplifier. So these amplifier, when we talk about the classes, class A, so this operation of the collector current will flow for 360 degree for the AC cycle. So here we can see that the collector current with respect to time t is about the 360 degree of the full cycle. Whereas class B, if we see, this is having the collector current which is flowing only for 180 degree. So here the conduction process take place in 180 degree and Q point will be there at cutoff. Class C amplifier, the collector current is flowing less than 180 degree. So this conduction period of collector current is less than 180 degree for class C amplifier. When we talk about the coupling, there are different types of coupling that we use in power amplifier. It can be capacitive coupling, the transformer coupling, the direct coupling. Capacitive coupling, if you can see, the output, which is the capacitor, it will be connected to the next stage of the amplifier. So it will block the DC and it will transmit the AC to the next stage. Whereas if you have the transformer coupling, this AC will be coupled through a transformer. When we talk about the direct coupling, DC and AC connected directly between the stages. So the second transistor is coming in contact with the first transistor output and it is directly coupled. So in this way, different stages of the amplifier will be coupled either in the form of capacitive, transformer or direct coupling. The frequency range also plays an important role depending upon the application. So if you talk about the audio amplifier, this lies in the range of 20 Hz to 20 kilohertz, and the radio frequency amplifier usually amplify frequency above 20 kilohertz range. For example, the FM radios, which is having 88 to 108 megahertz. So here we can see that the tuned RF amplifier circuit, so we can have the LC network which is used in case of the radio frequency amplifiers, and the next stage may have the capacitive coupling or it may have the transformer coupling as depending upon the application, but the LC network is the tuned network and which is used for RF amplifier tuned circuit. Narrow band or small range, and these amplifiers lies in the range of 450 to 460 kilohertz, whereas wide band are large range from 0 to 1 megahertz. So depending upon the frequency range, the amplifiers are classified into different types and they are given a suitable name for that. Signal level, when we talk small signal, which are voltage amplifiers, it has the swing less than 10% of the quiescent collector current. So we will be seeing the load line where the swinging of the point of the load line is less than 10% in small signal, whereas large signal amplifier use full load line application. The pre-amplifier will pick up the small signal, amplify it before passing it to the power amplifier, whereas power amplifier is the final stage. It will give the output power from milliwatt to hundreds of watt. So there are different stages and each stage will have its own way by which it will transmit the power, whether it is small signal, whether it is large signal, or it is a pre-amplifier. So again, when we talk about the load line, there are two types of load line. One is DC load line and another is AC load line. So amplifier behavior of DC and AC load line will intersect obviously at the quiescent point. This we have discussed very detailed what is quiescent point and how it is evaluated. So Q point location is critical for maximum output in large signal amplifier. So since our focus is on large signal amplifier, we have to see the location of the Q point, which plays a very important role in getting the output power. So if we differentiate the DC load line and AC load line, so let us see the DC load line. So in the DC load line, since it is the characteristic of the collector current and collector to emitter voltage, the line is known as the load line, and there are two extreme points that we get. One point is known as the saturation and other point is known as the cutoff. So in the saturation point, what is basically the collector current? So this is the maximum collector current that can flow in the transistor, which is given by VCC by total resistor of the collector and the emitter, whereas the maximum voltage that can be applied in collector emitter is the cutoff, which is the collector voltage. This point or operation of the load line can be at any point on the load line. So the quiescent point can be located anywhere. So it moves with changes in the biasing. So what value of the biasing we are applying, depending upon that, the Q point will change. For example, like in this circuit, we have voltage divided circuit. If we vary this resistor R2, then the Q point will change in the operation of the load line. When we talk about the AC load line, the slope is steeper than DC load line because it has a lower resistance. In that case, the collector current we can obtain by the equation of the AC circuit. So this is the AC circuit where all the DC parts are removed from the previous network that we have shown in the voltage divided circuit, and only the AC part is there. And it is much steeper than the DC load line. So AC load line we can see and the DC load line we can see on the same curve, and we can obtain the saturation and the cutoff point of IC and VCE cutoff using the equation of collector current and the collector to emitter voltage at the saturation level. So here the circuit that we are using mostly remove all the DC parts, and we have only the AC part at the output. So maximum peak to peak output will be always less than whatever the voltage we are applying in the collector, less than VCC. So that is maximum peak to peak output. So large signal amplifier will require the clipping. So clipping is very important. And what are the causes of clipping? If we talk about the cutoff, then the Q point will be too low and the signal will be driven into the cutoff. So here we can see the cutoff clipping. So here you have the Q point, and this Q point is very, very low point, and signal is driven to the cutoff point. So this is the cutoff point. When we talk about the saturation clipping, so Q point is too high. So this Q point is moving and changing the signal driven into the saturation region. Both these cutoff and saturation clipping will lead to signal distortion and poor sound quality. If we talk about the ideal design, then the Q point has to located in the middle of the AC load line. So this point Q point should be at the middle of the AC load line between the saturation and the cutoff, and hence it is maximum unclipped output that you will get. So unclipped peak to peak output is known as AC output compliance. So here when the Q point is located at the center of the load line, we get maximum output, whereas when clipping occurs, either cutoff clipping or saturation, we have maximum distortion. So the peak output that we get, maximum peak output, will be the minimum point of the ICQ into RC, the collector current multiplied with the resistor of the collector, and collector to emitter saturation voltage. So that will give you the peak output. If we talk about the maximum value of this peak output, that will be twice of what the value we calculated earlier. Optimum Q point condition will be that the collector to emitter voltage Q point will be equal to ICQ into RC. So the optimum emitter resistor that can be present in the network can be found out by this equation. So the Q point location plays a very important role in getting the maximum output voltage, and it has to be on the center of this load line. Then we can get the maximum output in the voltage amplifier. So this was the first part, very introduction of the power amplifier. In the coming lecture, we are going to discuss the types, class A, class B, class AB and class C in detail with their circuit and their application. Thank you for now. See you in the next lecture.